Hi everyone, we are Team Minerva. Our topic is how to engage primary school students to learn mathematics, especially for division operation. Here are the outline of our presentation today. Firstly, the primary and secondary research will be given, and then the concept including brainstorm and prototype will be introduced. Finally, the user evaluation and refinement will be demonstrated. Based on the design process of design thinking, we follow 5 steps to develop our project. Emphasize, define, ideate, prototype, and design. The problem statement is that design a solution that helps understand the essence of division in an engaging, intelligible, and home-like way for primary school students who may be struggling with learning division in mathematics. The target user is a student aged between 7 to 9 who may be struggling with learning division in mathematics due to the inattention and lack of understanding. And also the teachers are included. Teachers who are looking for a tool to help them teaching and division easily. First, let's jump to the research part. This table is the research progress. It shows the research we have done, we are doing, and what we will do in the future. The research techniques include the interview primary school teacher and students and their parents. We also did a primary school visit. Talking about secondary research, we found some more existing solutions and published research. Moreover, we did a market visit. We got some feedback from primary school teacher. As Vita introduced, computer and exercise is a method they currently use to teach the division. Also, they sometimes use a platform to record the learning progress of each student. In addition, we did an interview with the student parent. As he introduced, teacher used whiteboard and graphic to guide the student how to divide a circle into equal parts. He provided us new 2 technologies, the mathematics and Kuman. What the parents expect is that the teaching method should focus more on the process rather than the answer. He hopes there will be a more interactive application to increase the students' confidence. The primary school observation suggests that students tend to be more active on competitive environment. Some existing learning platforms do not show the complete problem-solving process. For example, the mathematics. And students understand the problem context better when their familiar environment is introduced. For example, including the problems with family members, favorite character, and so on. Then, I will introduce some existing solutions about the division teaching, including low-tech, high-tech, and some special network from the interviewer. The low-tech teaching method, especially for division, including the division worksheets, the printables, the division matching puzzles, and the books. In addition, the high-tech teaching method towards division are the division video, mobile applications, and the websites and some online games. What's more, I will introduce some special applications in this area. First, the Jumpido is a Kinect-based game developed by Kiru. It can invite the students to solve their problems using their body, which is attractive and interactive. And the Mathematic and Kuman, which is introduced by our interviewer. First, the Mathematic is an educational software developed by 3P Learning Company. It can help students to master their mathematics in an online learning space. And also, it can support classroom and home learning. And about Kuman, it's an educational network developed by Taru. And also, it can provide worksheets for students to practice the calculation. In addition, it is outstanding efficiency, but sometimes it would be rigid. We also did some market visits in Kmart to find the toys which could be related to division. Surprised, we found it rarely to find the toys designed for students to learn division. The only one but not completely related to teaching division is called the catch gesture. It has the operator of division. Moreover, we found some published research which focused on the keys of the children-computer interaction, the factors affecting the development, and the children's development stages. Then I will talk about our problem space. To summarize the issue, division is the most difficult operation for primary students to learn, and it is hard to connect division with home life thing. Also, students are hard to concentrate on the learning materials for a long time. Students have different styles of learning. Finally, a more engaging teaching method is needed for both teachers and students. Talking about ideation this time, first thing I'd like to mention is that we did a workshop to brainstorm the idea based on the issues we find from our research. We ensure the idea need to be targeted and specific and be able to connect division and home life things. And it need to be attract the students to attention for a long time, and it can provide different styles of learning. We found that there are three main types of division learning for students who have different learning styles: the instructions, the experience, and the application. And also the teamwork is really important for them. We also did some technology survey for the ideation. Firstly, the participants showed a greater performance in the short-term and long-term mnemonic, the effects in the Kinect-based condition, than those in the mouse-based condition. Also, the implementations of the Kinect math in school mathematics classroom have been highly positive. Finally, most of the school students provided the positive feedback of the Kinect-based kinesthetic learning applications in the research, and were able to reproduce several graphs and patterns with the Kinect.
Now we move on to the prototype part of the system. One of the concepts we came up with is now called the mirror. It is a high-tech student-centered teaching tool where it targets the division issue by connecting the division with home life things like shopping. Also, it allows the user to choose their interested topic or scene and provides instant feedback on their actions. We developed a Wizard of Oz prototype to evaluate the usability of our concept on the target users. In a prototype where the PowerPoint slide is used to construct the text and animations, laptop camera is used to be the Kinect sensor, in which one of our teammates controlled the slide in private so that the user may believe that the system could detect and respond to their movement. We also put the shadow-shaped pictures in the slide to simulate the participants' avatars in the screen. We divided the prototype into three main parts. First one is instruction, where kids are taught the basic concept of division operation. Second one is experience, where they get to know how it works. And the final one is application, where they basically can practice to apply their knowledge in everyday life. We built this based on different focus groups, because we understand that kids have different learning ability. In stage 1, we teach the basic concept of division with kids. We hope that by letting them observe the logical reasoning behind it, they will understand the concept better. While in stage 2, we let them interact with our system, where participants should stand in front of the screen or Kinect one by one. The apples will be automatically distributed evenly in terms of number of participants. As continuation from stage 2, stage 3 mainly focuses on practicing the previous knowledge to be applied in the future. There is also a reward system if you successfully completed all of the models. The diagram shows the logical workflow of our Wizard of Oz prototype, in which one of our teammates will act like a computer according to this logic in order to make the user believe that they are actually interacting with the real system. The goal of execution is the difference between the intentions of the users and what the system allows them to do, or how well the system supports those actions. The goal of evaluation is the difficulty of accessing the state of our system and how well the artifact supports the recovery and interpretation of the state. The goal of execution and evaluation of the stage 3 of our prototype. We meet our users in person to observe how they interact with the system, then evaluate them. We have 3 participants with different learning abilities and familiarities with division operation. The first attempt is to observe just one girl without her friends, as they have not yet to come to the venue. First thing we noticed is that the kid didn't pay full attention to the teacher and the system. She tended to avoid eye contact with the teacher, and sometimes she turned to her father and refused to answer questions. There are lots of long pauses where we waited for the kids to answer. Happened during the testing session. Right after the interview, she said to like the prototype and understand what she was doing. Her father said she was shy because she is surrounded by strangers, so she was hesitant to interact with the system. And her father also considered that she would be more active if her friends were here, so he invited them. This is the second attempt where we invited more friends to come over. As soon as they arrived, the girl in the first testing session insisted that she also could join the other part. So in the end, we have 3 kids participating in the testing, say it with each other, without their parents. The kids were willing to talk to the teacher and each other. And surprisingly for the first girl, she's so energetic and competitive in the answering question. One kid even told the teacher a personal story. The kids show interest in interacting with the system, and the kids use fingers to move the objects, so they understand the system intuitively, which is good for us. They could focus on the system and teacher for a much longer period. Based on the video, we can tell that our conclusion is that kids feel more comfortable when they work and study with their partners. And this is a good thing because our system is ideally suitable for multiple users. Working on learning together may be a key element to improve children's attention. The issue that we found here is that the kids may need more instruction to understand the purpose of the prototype. And sometimes they get confused about what they need to do next. We summarize users based on these 3 items. First one, engagement level. 3 students were quite active in the game and they enjoyed moving the items on the screen. No one's looking away or secretly hide or avoid the system. The second one is interactivity. By attentively looking at the question, picture, and answer, as well as move the item on the screen to do the next step, we can tell that they interact with the system very well. And the third one is the most important part. It is to keep their attention. Firstly, when one student enrolled, the student was shy and didn't pay attention to the system. However, when her partners come join, she became interested and decided to move along with them. And for the difficulties level, there is no difficulty level of the system because the flow is basically controlled by the teacher. So the implication is that the kids feel more comfortable when they work and study with the partners, and working or learning together may be a key element to improve children's attention. However, we face some limitations. Teacher controlled rather than students. This could be a huge problem in the future because we want students to interact with the system collaboratively. Using computer screen to show the content cannot make users feel like it's a real experience, but since it's our first initial prototype, we're still doing it. So what's the next thing that needs to be done? First one is do more research on the target users itself and explore the interaction of the technology. We need to refine our concept details and improve them. And the most important thing is probably to make a prototype because as for now we only have a Wizard of Oz prototype, so it's not a real prototype, and we started building the technology part of the system. Start thinking about the features, functionalities and stuff. We also need to do some evaluation based on the iteration and evaluate with more students in the classroom environment and test whether the prototype could help students increasing their math ability or division. And more on prototype functionalities. We want to create one-by-one participation system. For example, if someone stands in front of the system, that person will get to have all the apples and will be the first one to share. And after the first person is finished, she or he can give the authority of giving away all the apples to the second person and go on. We also want the user preferences to go on. We want to have a user to be logged in as teacher or student. When the calculation fails or show the wrong result, the system will notify this failure in the system in a comedic way, encouraging students to try one more time. There's also a leaderboard to make and reboot the competitive environment in students. However, only the top 3 will be listed. This to prevent other sole learners from being hesitant with the system. Here's our references. Thank you for paying attention in our presentation. See you next week.